Hey, I am live. That's kind of cool. Alright, well, now that I see the stream up and running, thank you for stopping by and checking it out. So what we're going to be doing is a little bit of live labbing, where I'm setting up a new topology, as you can see. This is Eve Pro, and it's running on a physical server. So what we're going to be doing is I'm going to be bringing over my Super Putty window, where we will be going through and basically configuring the MPLS VPN here at the bottom. And it's not a huge core MPLS core, but it's still, it's decently sized. And the purpose of the MPLS VPN is basically to allow us to test any things like get VPN over MPLS, and anything that would be riding over MPLS as like DMVPN and stuff like that, and a lot of those capabilities. So that's going to be what we are going to be playing with as we go forward here. Now it's going to probably take us a little while to get all this configured. I've got the subnets laid out. So for example, R9 and CSR11 will be that'll be like 10.11.9 or something along those lines. So as we go through here and configure everything and get it all running. So we're going to do that, and everything's going to be peering via BGP for all of our configurations. So these ASAs and these routers, I'm not sure if I'm actually going to spin them up or if I'm just going to configure the MPLS backbone, but we'll come to that when it comes down to it. So we're going to configure everything from scratch. So there's one thing I have left to do, which is I have to on CSR14, which is in the lower left here at the bottom, I actually have to come in here and do a show run section license to see if I need to enable the license on this CSR so that it can support advanced capabilities. So if I decide I want to run encryption anywhere in here, I can do it. So we're going to go to global config, and then we're going to type in license, boot level, and AX. Now, there's a couple of different options you have, but we're going to go with AX because it basically adds all of them to it at the same time, and we're going to hit the enter key. Now, you have to save the config when you do this, but what we're going to do is we also are going to do the license accept end user agreement. We're going to say yes, and it jumped off screen. And we're going to then jump out of global config, we're going to write mem, and then we're going to reload the box. So we're going to reload that. While that's in the process of reloading, we're going to go ahead and start the IP addressing in the core, and then as we're going along, we'll be enabling OSPF and MPLS as we're going. So the idea, as we're going from left to right, is I'm going to start off on CSR11 because he's already good to go. So I'm going to come up here, hostname, CSR11, and then on interface, gig 1, no shut. IP address is going to be 10.9.11, 10.9.11.11/24. But as we're going through the process of setting all this stuff up, this is a lot of the stuff that you guys don't see behind the scenes. So if we do a do show IP interface brief, the interface is up. We'll also have to create a interface loopback 0. IP address is going to be 11.11.11.11. Most of the time when I set this stuff up, I'm going to configure it so that it's all the same subnet, so I can do a single advertisement, which is pretty much what I'm going to do right now. I'm going to type in 192.0.2.11/32. I think that's enough 255s. Yep, that was enough. So let me go ahead and stretch this out just a little bit further and get this all squared away. So we have all that good to go, and what I'm going to do is on the I'm going to go ahead and enable OSPF and MPLS at the same time, so that when we're going through this, and by the time we get to the end of the route, the edges of the MPLS backbone, we should have routing adjacencies and LDP running, and then we'll have to set up BGP and the VRFs and all that type of stuff. So what I'm going to go and do is a router OSPF1, type a network statement of 10.0.0.0.255.255.255 area 0, and I'm going to type in MPLS LDP autoconfig. Now that I have that going, I'll also type in network of 192.2.0.0.0.0.255 area 0. So that'll allow me to advertise the loopbacks and all that good stuff as I'm going along. And then all I have to do is work my way through the routers, through the rest of the backbone. Once all that's set up, all the routing adjacencies should come up as they're going along. So the next box I'm going to jump on here is router 9, and go from there. So that's basically how we're going to play this game as we go along. So now, any of the routers that are showing up like this is just regular IOSV. Any of the routers up here, these are CSR 1000Vs. So I'm going to go ahead and go to global config and interface gig 0/0. IP address is going to be 10.9.11. I think that's what I used was 11, or was it 11? Not yet, 9.11. .9/24. And no shut that interface. And then I'm going to work my way around all the physical interfaces. Then I'm going to spin up the loopback and enable OSPF on all of them at the same time, so that we're not having to go back and reconfigure anything. So I'll type in interface gig 0/1, and I will, this will be 9.10.9. I'm sorry, no, 8. Going towards gig 1. So make sure that you're paying attention to what you're doing there. And then no shut that interface. And then we'll go to gig 2, and that's 9 to 10. So we'll go .10.9, and then no shut that interface as well. Interface loopback 0. IP address is 192.0.2.9/32. And then we'll exit out, and we'll type in hostname is going to be R9. And then router OSPF 1. One thing that's cool about this configuration once it's done is we type in do show run section router OSPF. We can literally take this config like this and just dump it onto here, and everything should just start to work. Now, obviously, OSPF has that slow, it's got that 40-second wait timer, so we have to wait a little bit, so don't be freaked out if it doesn't fire up right away. But the adjacencies came up, and we should get an LDP adjacency between R9 and CSR11 here in just a moment, and there's the LDP adjacency. So we're going to continue to move forward, and I'm going to jump on router 8 and work my way around. So type in hostname, it's going to be R8, and then we're going to specify facing towards R9, we're going to say interface gig 0/0 or gig 0/1. IP address is going to be 10.9.8.8/24. No shut that interface. And then gig 0/3, same concept. Just reapply the addressing. And this will be 8.10.8. No shut that interface. And then we'll have the point towards gig 0/0, so interface gig 0/0, and bring this guy up. This will be 8.12.8, and no shut that interface as well. Interface loopback 0, IP address of 192.0.2.8/32. And then we exit out, and we right-click and paste in our OSPF config, and that's what makes the beauty of this config work, is it's quick. So let's just verify that all the interfaces are up. They are. So there's the adjacency starting to form. We'll jump onto router 10 and get him squared away. Once we have this done, we'll be able to dive into the MPLS the BGP config, and we'll probably just do a PE to PE full mesh peering, because it's, I don't really need to spin up a route reflector. This is router 10, so it'll be R10, and then on R10 we'll type in interface gig 0/0, IP address of 10.14.10/24. No shut the interface. Pull up gig 0/2, and we're going to say that is 9 to 10. So this should be, what happened there? Okay, that brought that up the interface. Okay, so let's pull this up and go find the addressing again. So it should be 9.10. Let me just double check that real quick. And we have 9.10. Yep, that's correct. 9.10. So we'll type in 9. 10.10, and that'll bring up that interface. We'll type in interface gig 0/3, and we'll hit the up arrow, and we'll type in 8.10. So this will just be 8, or no shut that interface as well. And interface loopback 0, IP address of 192.0.2.10/32. And do show IP interface brief. Make sure we didn't forget to no shut an interface. We didn't, so we're going to go ahead and just copy that config into play, and we're good to go. So as it sits right now, all of our core routers are squared away. Now we just have to bring up 12 and 14, and they'll be squared away. And CSR2, let's do a quick check to see if licensing is applied. Section license. Licensing has been applied, which means I can just jump in here and get this configured. So hostname is going to be CSR12, and then we're going to type in interface gig 1, the IP address of 10.8.12.12/24. No shut the interface, and the interface loopback 0, IP address of 192.0.2.12/32. Is that enough? Nope, one more. And then right click and paste in the config there as well. And hopefully CSR14 is loaded by now, and it is, so that's a great sign. So we're going to type in hostname is CSR14, and we're going to type in interface gig 1. IP address is going to be 10.10.14.14/24. No shut the interface. Interface loopback 0, IP address of 192.0.2.14/32. And that's it. That's pretty much our config. In a matter of, I don't know, 10 minutes or so, we have our core built. And so what that means is simply MPLS and OSPF. So now once we'll wait for the, so the OSPF adjacency is up now to router 10, and so should the LDP adjacency here in a moment, which is that. So now we just need to verify the routing table. So I should see do show IP route OSPF, and I should see some OSPF routes. I see 8, 9, 10, and 11, and 12, which is exactly what I should see. Do show MPLS forwarding table, and I see label values for, let me highlight this real quick, 8, 9, 10, 11, and 12. So that's exactly what we need in our backbone. So now what we need to go do is, like I mentioned just a moment ago, instead of going through and doing a route reflector and a bunch of other stuff, we're going to simply do a full mesh of PE to PE connections. And I'm probably just going to use a peer group to configure it. It'll be a lot easier to go do. So what I'm going to go ahead and do is I'm going to start on CSR 11, and I'm going to back out here. I'm going to use, I'll use router BGP 100. Now I'm a big proponent of being able to scale BGP, so I'll type in no BGP default IPv4. So using that command simply disables the automatic IPv4 peering capability. So in order to spin up a IPv4 unicast peering, you have to go in and manually activate it. I'm not going to be running IPv4 unicast. I'll be running the address family VPND4. So what I will do is I'll type in neighbor, and this tag number is going to be IBGP. And I'll type in here will be a peer group, and hit the enter key. Now I've created the peer group. I'll come in here and say remote AS is 100. The update source is going to be loopback 0, and hit the enter key. That's really all I have to type in. So now I get to type in neighbor of 192.0.2.12 and say peer group IBGP, and do the same thing with CSR14. So those two, and then I can come over here and I can say address family VPNV4, and I can just say go up to this one here, back this up, and say activate. Now what's going to happen automatically behind the scenes is the send community extended is automatically going to get added. So then I can just come in here and type in 14, and now I have two BGP configurations squared away in order to get that set up. So now what I get to do is type in show run pipe section BGP, and now I can take a notepad doc like this, and I can simply copy and paste this guy into Notepad. And by doing this, what I'll do is I will come over here and type in, I'm going to be jumping onto CSR 14. So normally what I do when I do this, I want to go to whatever what I'm going to be going to. In this case here, it's going to be CSR 14. I want to swap this to be 11 and this to be 11. See what I did there? So I ended up moving the config over. I'm going to go ahead and whack the exit address family config. And I'll come up here, I just copy and paste all this in. I'll go to CSR 14 and I will exit out of this one, and I will right click and paste that command, that line of config in. Now that I've got that in there, I'm going to go to CSR 12 next. CSR 12 is up there, so for 12 I'm going to come over here and type in 14 here and 14 there. So that allows me to take the config and just copy paste, and all the routers will be up and running. There's the first BGP peering there, and I will right click and paste that in there. So by the time this is all said and done, I'll have the full peering of connections between all of the routers here in just a moment. I'm going to go ahead and minimize that now. So there I have it. So if I jump out of global config, I do a show BGP VPN v4 unicast all summary. I have two peerings, one to CSR 11, one to CSR 14, and I'm good to go. The next step is we have to configure the VRFs. And once we do that, that's the core configuration. Everything else beyond that is just going to be PE to CE connectivity. And I could use static routing, BGP, whatever the case might be. So I'm going to simply, since I'm on CSR 12, I'll go ahead and create the VRF there. I'll type in VRF definition because I want to maybe use IPv6 in the future. So I'll type in here, we'll say secure, we'll type in VPN because that's what the majority of this topology is going to be used for. Then I will come in here and type in the route distinguisher is going to be 100:100, and the the route target, and there's a command both in iOS that you can use and say 100:100. It's going to allow you to apply that value to the import and export policy. So that's pretty much what's going on. So I see a few people have joined the stream, so thanks guys for hanging out with me. If you have any questions, post them in the chat below. I'll be able to answer them live here. If not, just hang out and watch. So what I'm going to do now is I actually have to enable the address family. If you don't enable the address family, you won't be able to learn any routes. So I'll just come in here, type in address family, IPv4 unicast, and that's it. Now what's cool about this command, if you do a do show run section VRF, is by applying the route target outside of the address family, so whether it's IPv4 or IPv6, what that does is it applies that route target import-export policy to all the address families, so both IPv4 and IPv6. So I'm going to go ahead and I'm going to grab this config right here, and I'm going to drag and drop it into CSR 11, and it doesn't matter where you type it in, iOS will take care of that for you. And on 14, I'll do the exact same thing because I want the same import-export policies. I'm not going to play the game of, one PE has one policy, one PE has another, then I have to go and add import rules. If this was a service provider example, I might be doing that, which it's actually kind of, the irony is this is a service provider MPLS setup. However, I'm trying to keep it as vanilla as I can in case, you guys don't have a background in MPLS. So that's basically where we're at. So the next step that we have to do is on the interfaces that connect down to things like CSR R6 and this ASA, which the ASAs that I'm running, the versions of code that they're running, support BGP. So what I'm going to do is I'm going to go ahead and come in here, and you guys are going to get a tree. I'm going to go ahead and spin up ASA v3. I'm going to start that firewall, or start the ASA up. Now, you might notice in the upper right hand corner I'm getting a bunch of failed to create network. I do get that problem every now and again when I'm running Eve, and I only get it on this specific server because it's a bare metal install. So it might be something on the back end with the server, I really don't know. But either way, what I'm also going to do is I'm going to spin up router 7 and connect to him. It takes a couple times to get it to spin up, and while they're spinning up, I'm going to go ahead and configure the connections between the CSRs, at least the subnets. That's not going to take me very long. And then what I'm going to do is I'll do a couple of peerings just to show what that's going to look like so we can get end-to-end connectivity squared away via MPLS. So hopefully this will become something I do on a regular basis where I do a live stream every now and again. This is the first time I've done this, so it's actually kind of cool. So we're going to go ahead and pull up. One thing that's cool about the way that I have Firefox configured is it automatically pulls up the application for Super Putty. So if I just click on, say, R7 here, I can click on it, and that's going to pull up Super Putty, and it's going to point the telnet session to the IP address of the IP address of the server and the port number. So I'm just going to come in here and type in rename, and I'm going to put this as R7. Now I'm going to put on the outside of these because I know it's a PE, or I'm sorry, it's a customer edge router. Do the same thing here. It's going to pop that guy up because that'll be an indication to me that it's a customer edge. So I'll type in R6 and get that guy squared away. And for your viewing pleasure, I'll even do the ASA because I'm just that kind of guy. So I'm going to right click here, rename tab again, and just type in ASA. I think that was ASA 3. We'll find out here in just a moment. Ta-da! I'm right. So ASA 3 is currently booting. Actually, it's already booted. So what we'll do is we'll come in here. Now, if you're logging into an ASA and you are getting this, the password, if you did not already set a password for the ASA, there is no password. Just hit the enter key. So I'm going to go to global config and enter through that and type in. You can answer the question by saying no, but I don't worry about that. I'm going to come in here and type in host name is going to be ASA3. And then I'm going to go ahead and on the outside interface, which is going to be gig0/1, I'm going to type in interface gig0/1, type in IP address. In this case here, I've got ASA3 to CSR11. So I will type in 113.0.0.3/24. No, shut the interface. Name if is going to be, and I'll say MPLS, just so that it's easy to determine what's going on. Now that I have that going on, show interface IP brief. So we have the interfaces up. I'm going to go to CSR11, and on gig 2, so we'll type in interface gig 2, do show IP interface brief to verify the configuration. There is none currently. So I will type in interface, I'm already underneath the interface. Now if I apply an IP address to it, then I put it in the VRF, it's going to strip the IP off. So I'm going to type in VRF is going to be VPN, or sorry, VRF forwarding VPN. I'll type in IP address is 113.0.0.11/24. And that's pretty much it. There's really not a whole lot more to it than that. Now I want to set up the BGP peering to it. So I'm going to type in router BGP 100. I'll type in address family IPv4 VRF VPN. I'll type in neighbor of 113.0.0.3 remote AS, and I'll just use 65103. And then that'll be all I need to type in. The VRF config that takes care of the rest. So now in the ASA, I'll go type in router BGP 65103. I'll type in the, I believe, I type in the address family, and I have to specify IPv4 and unicast. I think if you hit the enter key, it'll just go in there and do it. So we'll type in neighbor of 113.0.0.11, and we'll type in remote AS of 100, and hit the enter key. Now, I don't have any routes currently configured yet, but I'll go ahead and advertise one in right now. So network is going to be 10.1.1.0 with a mask of /24. And that's pretty much it. So there's no logging enabled on the ASA by default, so eventually that peering should come up, assuming that I do show IP interface brief. Hey, what do you know? Interface gig 2, no shut. Forgot to no shut the port. It does happen. So once that happens, the peering should come up, and we'll have a peering to see it to ASAV3, and the interface is now up. The peering to the ASA should come up here in just a moment, and that should work. I'm just hanging out for a moment until it does. And are we going to get lucky here? Let's see. Do ping 113.0.0.3. Oh, what do we not? What don't we have working? So this is a lot. This is a physical interface. So let's see here. So we have a little bit of troubleshooting. Do show IP interface brief. Do show run section BGP. All of that seems to be in working order. We can't even ping the ASA. So what's up with that? So let's go over here and do show, or no, show interface IP brief. So the interface is up. Ping 113.0. Oh, well, they're directly connected to each. Oh, I know what I didn't do. I did something. I goofed up. This isn't a valid command when you're dealing with the VRF. So I'll type in VRF VPN. There, that ping worked. So that's how you fix that problem. So now, why is that not forming appearing? Let's do show run section BGP. I am using AS100. And I have appearing down to 65103. This is ping 113.0.0.11. I can ping that way. Show run router BGP. And that is, oh, there's what I did. I have the wrong IP address in there. That'll do it. Remote AS of 100, and then we'll do the activate command. That'll activate that connection, and that would be the reason why. And there's our appearing. So if we do a do show BGP VPN v4 unicast all and hit the enter key, we haven't learned anything yet, but we do have appearing towards that particular route. And the reason, even though on the ASA we've advertised the route of 10.1.1.0/24, the interface isn't up yet. So we do a show interface IP brief. We'll see that on gig 0/2, so interface gig 0/2, we'll type in IP address of 10.1.1.100/24. We'll type in no shut and a name if of inside. Pretty simple configuration. So now that we've done that, we do a show BGP summary. We'll see that we have show run router BGP. We will go into here and we'll pull that old configuration out that's incorrect. I'll just type in no neighbor. That'll remove that configuration. So show BGP summary. That gets that. Now we're not learning anything from CSR11, but CSR11 should be learning a route from us. So if we come in here and do this, we're learning the 10.1.1.10 or 10.1.1.0 because now that route is live on the ASA. So now what I should be able to do is over here on R7, type in no here to bring him up. And on R6, same thing, no there. Now it's going to take a moment for them to go through and get to the point where we can actually work with it, but that's pretty much where we're going to have to take a moment, pause, and actually they're going to come up a lot quicker than I thought they were, which is awesome. So that is working out just fine. Let me go ahead and adjust something over here because that's better. Perfect. Okay. No questions coming in. All right, that's cool. That works. Thanks for everybody that's joining. I've got 8 viewers. Wow, I feel special. So that's where we're at there. So now that that guy is up and this guy is up. All right. So the only thing I'm waiting on is R6 is to do that. Is the passcode signing verification. So we're good to go there. So now what I'm going to go ahead and do is on R7, I'm going to go ahead and for that CSR, which is CSR 12, and that's gig 2, I'm going to go to config T interface gig 2. I'll type in VRF forwarding is VPN. We'll no shut the interface, and then IP address of this case here is going to be 1. I had to be careful here because normally I would just say 127. The last time I checked, you can't do that on iOS. It won't actually work. So you have to actually type in 172.0.0. something. So 12 in this case is what I'm going to run with. No shut the interface. The interface is already no shut. So I'm going to go to router 7 and do the exact same thing. So global config hostname is R7, interface gig0/2, IP address is 172.0.0.7/24. No shut the connection. Now let's type in router BGP 65107. No BGP default IPv4, and a neighbor of 172.0.0.12, remote AS of 100. And then what I can do if I want to is I can advertise the 172.16 network in there. So that's pretty much what I'm going to do. So I'll go to gig0/1, I'll type in the address family, IPv4, and I will I'll activate the peering, and then I'll say network of 172.16.10.0 mask of /24. So that's pretty much all I have to do. Now I'm going to go back up to CSR 12, and I'm going to type in router BGP 100. I'll type in address family, IPv4, VRF, VPN, or VRF, VPN, yeah, VPN. And then underneath here I'll type in neighbor of 172.0.0.7, remote AS of 65107. And then what will end up happening is as soon as I learn, or I form the peering, I should learn any of the routes that are being propagated. Now, that's not going to be true for this connection because the interface that I'm advertising isn't actually up and running yet. So I'll type in, what was the interface? Is that gig 2? Gig0/1. So interface gig0/1. I'll type in IP address of 172.16.10.7/24. And I'll no shut that interface. So that'll do that. So then once that interface comes up and is good to go, I will do show IP BGP. So now notice how I have the route to 10.1.1.0. Now that's going to work just fine in most cases. The drawback to the configuration is if I try to do any type of connectivity to ASAV3, it gets dropped. And to my knowledge, there's no way if you try to do like the inside interface on an ASA to the inside interface of another ASA to bring up a VPN connection, it's not going to work. Same logic I think applies here. So what I will do is on the ASA, I will hit the up arrow, and I've learned one route. So I've got the 172.16.10.0. So I will go ahead and I will. One thing to note, however, is if you look here on CSR or on the routers, you'll notice that I've got the inside network propagated, right? Now, what that means, or why that's going to be difficult to get operational, is when I go to configure something, or I'm sorry, go to extend reachability, one of the things that we're going to have a problem with is the connected prefix. So this 172 network here or this 113 network here, those aren't advertised into BGP. So what I will do from an ASAV perspective, or I'm sorry, an ASA3 perspective, is I will attempt to ping 172.16.10.7 and hit the enter key. And you might say, well, it's not responding. That's true. And the reason why it's not responding is because the source interface that it's coming from is 113.0.0.3. So I could type in ping inside 172.16.10.7 and try that. And that's not going to work either. So what I end up having to do from the ASA's perspective is I'll actually have to spin up this Windows PC. And then I will have to I'll have to inspect ICMP here in just a moment to get that to work. So I'm going to go ahead and do that here in just a moment. And once I could inspect ICMP now, which is no big deal. So I'll just show run policy map, and then I will go to the global policy here, go to global config, and I will right click and paste in that and type in inspect ICMP. Pretty simple, pretty straightforward. So then what I will end up doing is on router 6, that's right there, on R6, since this guy's ready to go, I'll type in host name is R6, and I will specify that on the gig 0/2, so interface gig 0/2, IP address is going to be 172.16. Well, actually, that's the outside interface. So I will choose to do 126. So 126.0.0.6/24. And I'll no shut that interface. And on the CSR2 side, I will come in here and type in do show IP interface brief, which that should be gig 3. I see what happened there. Interface gig 3. I'll type in VRF forwarding is VPN, and then IP address is going to be 126.0.0.12/24. And I'll type in router BGP 100, address family IPv4 VRF VPN, and I'll spin up a BGP peering to that guy. So 126.0.0.6, remote AS of 65106. That's all I really need to type in there. I'll jump back over to router 6. I will type in router BGP 65106, no BGP default IPv4, and then the neighbor is 126.0.0.12, remote AS of 100, and then address family IPv4, and we're going to go ahead and activate that peering. And from the network command, I will advertise 172.16.100.0 with a /24 mask, and then type in interface gig 0/1, IP address of 172.16.100.6/24. No shut that interface, and that will be that. So now the propagation should start to begin as soon as the routes start to advertise. It might take a minute or so for it to actually propagate, and when it does, you'll see that. So on the ASA, if I do a show BGP, I should start to see more and more routes starting to come in, and we should start to be able to reach stuff. Now, I did spin up this Windows PC, and now here I am. I have this Windows 7 PC sitting here, and everything's looking pretty good. So what I'm going to go ahead and do is I'm going to go ahead and configure this Windows 7 PC to point it to its default gateway of the ASA. So I'll come in here and open network control, the interface stuff. I will say properties, and come in here, and I will type in here. This guy's going to be 10.1.1.10/24, and then 10.1.1. I think I used 100. Show interface IP brief. I did use 100. I don't know why I chose 100. Usually I choose .1. Now I don't have to worry about DNS for the moment because I'm not enabling that yet. Now, one thing that I've commonly found when you're, okay, so I did get connectivity on the interface, which is good. I'm not doing DHCP, so no worries about that. So I'll let this finish its thing up. One thing I'll have to do is I will actually have to go through and enable it to respond to ping. So we'll go ahead and click cancel there. And from, that should be fine. And if I bring this over a little bit, and I think this is R7. So from R7, the question that I get a lot is, should you be able to ping through? Because you're going from a low security level to a high security level. And it's a good question. And the answer is I should not be able to reach it. So if I come in here and do a ping to 10.1.1.10, I shouldn't be able to reach it. And they might say, well, how come you're not going to be able to reach it? Well, on a firewall, the firewall rules are, on the ASA, it considers itself to be on the outside interface. So you didn't bring the session in. But if I go to here, I do a show IP interface brief, and I look at 172.16.10.7, and I go to the PC on this side, and I pull up the command prompt, cmd, ping 172.16.10.7. Let's see if I can ping this way. And I can. Now, that's a great sign because that shows that there's end-to-end connectivity. So let's do a trace -D to 172.16.10.7 and see what we see. So we're going to trace through. The ASA will be hidden because I have not enabled. It's going to fail quite a bit actually, and there's a couple reasons for that. Now I'm going to let that run for the moment, and I'm going to bring this guy. Let me move this up a little bit, and let's fix this so that it doesn't fail. So I'm going to go ahead and pull up ASA 3. And on the ASA, I'm going to have to go to global config and show run policy map again. And in the policy map, I have this. I have to go to this global policy and type in class/default. And underneath here, I have to set the connection to be decrement TTL, and that'll allow the ASA to show up in the transit path. And I also had to create an access list. So access list, we'll say ACL outside in, and I'll type in extended and permit. We'll type in ICMP from any source to any destination, as long as it is a what is that? A time exceeded or an unreachable. Any unreachable. So now that I have show access list, I have the ACL configured. Now I just have to apply it. So we'll type in access group, and we'll type in ACL outside in, even though I spelled it wrong. Outside in interface outside. All right, MPLS, sorry. So now that I've got that applied, let's go and try this one more time. So this should fix this problem. Let's hit the up arrow, and the ASA should be in the transit path, and then we're getting it, so 10.1.100, and we're getting that to pop through, and so we have end-to-end reachability. We see all the hops. So now that's a great sign. So now what we get to go do is, let me go ahead and minimize this for the moment, bring this guy back up here, and so R6 should be squared away. The peering should be up. Do show IP interface brief. So the interfaces are up. Do show run section BGP. Why did the BGP peering not come up? Let's see. CSR 12. Do show IP interface brief. Again, forgot to no shut the interface. No shut. We'll give that a couple of minutes. But anything really past this, we're pretty much done. We've done everything we need to configure and stuff like that. So, and there's the connection that we have up. We're going to go back to router 6, and we will say show IP BGP. I'm learning a few routes, which is awesome, and stuff like that. Everything looks pretty good. So now I can go to this, and for example, I could do a trace route from 6 to 7, but it's going to be pretty short-lived. So we'll do a trace to 172.16.10.7 with a source of, what do we have in here? The gig 172.16, 172.16.100.6, and we'll do it numerically so we don't run into any problems. And we are connected to the same provider edge router. Now you might say, why did you have to throw the source in there? Well, the reason why I had to throw the source in there is because the external prefix, so the outside IP of 126.0.0.6, is not advertised into BGP. Only the internal route is. So I have to source the traffic from the correct IP address or interface in order for the traffic to be sent. So that's pretty much it. At this point, that is almost everything I can think of to get operational and all of that good stuff. So that's pretty much MPLS when you need to do it end-to-end. So since I'm still live and I have a little bit of an audience, I figured, you know what, let's have a little bit more fun. And what I'm going to go do is I'm going to go ahead and enable internet connectivity into the Eve environment. So if you guys have never seen that, we'll go ahead and test on that real quick just so you guys can see how that works. So one of the things we can do is you can create this network here, and this add network thing. You can name whatever you want, but the important thing is to do is in this drop down box is choose management cloud, which gives you external access it outside of the box. So box meaning the server, Eve is running on top of that, and whatever the interface it is that you're using to connect to the Eve instance. In this case, here I'm using the management interface. Well, by leveraging that, which is exactly how this guy's configured, if I edit this, it's management 0. Because I'm able to do that, I can actually go to this router. I'll go ahead and power it on. And I don't need anything fancy on this router in order to make this work. One of these days it'll start to boot. Sometimes it takes a few times. Start. Okay, there we go. So I'm going to go ahead and click on that to start it. And then we will go ahead and let it boot up. It's going to take a couple of minutes for it to boot. And once it does, then we'll go in and do a little bit of configuration on it in order to allow internet access into the Eve instance. And then we'll configure ASAV3 to allow Windows 2 to connect outbound, which will only take us a couple of minutes. As a matter of fact, I'm going to go ahead and do that now. So, I shouldn't have clicked off. So that we can, by the time the CSR is up and running, we can just enable the routing that we need to enable. And so we'll do a little bit of NAT on there through an object group. So on the ASA, we do interface gig 0/0. We'll come in here, type in IP address. In this case here, we're going to type in, this is going to be, we'll say 30.0.0.3/24. I'll type in name if is outside, and we'll no shut the interface. So we have that, and then show interface IP brief. So that's good to go now. I can go ahead and exit out, and I will go ahead and say an object of network, and we're going to type, we'll say LAN, and then we're going to type in the network, I'm sorry, the subnet is going to be 10.1.1.0 with a /24 subnet mask. And then we'll come in here, we'll type in NAT, and we'll say from the inside to the outside, and we're going to come in here and say that it's dynamic and use the interface IP address. So that's the NAT configuration, pretty straightforward. And then what we'll do is we'll create a default route, so route outside 00, so basically a catch-all, and type in 30.0, yeah, that was right, 30.0.0.1, and hit the enter key. So with that done, I have all my routing is ready to go, so show route. I can do a show NAT. The NAT configuration is ready to go, and I'm ready to rock. I'm just waiting for the router to boot. Now, once the router boots, I will form an OSPF adjacency between this router here and my home router. So you might be saying, well, how are you going to pull that off? Well, I'll pull that off because this connection that I have right here leaves the Eve instance. So the CSR, and I don't need to do anything fancy with the CSR. I don't need to enable any type of advanced configuration because I'm not going to be doing security or voice or anything like that on it. So I just have to give it a moment to boot up and do its thing. So it should be almost done. And once it is done, I can go ahead and allow that connectivity in. And the Windows PC should be able to reach the internet here. One thing I'll have to do is on the Windows PC is I will have to, oh, that's weird, it got internet access. How did that happen? Because I didn't configure any DNS. Properties. TCP/IP properties. That's unusual. 8.8.8.8. We'll click on OK. Close. Close. On here, we'll type in ping 8.8.8.8. Yeah, I thought that was a little too good to be true. So I'll go ahead and I'll cancel this, and I'll hit the up arrow, and I'll do a -T to keep it continuous. And now the CSR is ready to go. So we'll go to global config. I'll move this guy out of the way, and we'll go to global config and type in interface gig 12 no shut, and we'll type in IP address is DHCP because I have DHCP enabled on that for my management network of all my nodes. And what'll end up happening is let's see here. Okay, there it goes. So now that we've got an IP address, so do show IP interface brief. We're going to go type in interface gig 2 and type an IP address of 30.0.0.1/24. And I'm going to go ahead and type in router OSPF1, type in network of 10.255.1.0, 0.0.0.255, area 0. And that will allow me to form an adjacency with my router. So I have a 30.28.51. So, and there's my adjacency, so we know that's good. So do show IP route, and I have a default route pointing towards my home router, which is awesome. So now what I get to go do is, now that I have that squared away, I have to go and, let me go ahead and bring this back over. You'll notice that the ping is still failing. And you'll notice also that the little exclamation point is there now. Completely okay. But one thing we have to do now is I have to log into the router, my home router. And let me go ahead and do this. And we'll log in. And one of the things I have to do is, this is a 2851. So if I do a show IP access list, I have all of these different subnets that I'm allowing to be natted outbound. So anything public that you might see in my lab, whether it's whatever it is that I'm doing, you'll always see, I'll have to allow ACL, call an ACL to allow it to NAT. So there's actually two NATs that'll be happening, one on the ASA to allow Windows 2 outside of the ASA, and then a second NAT on my home router. So I'm just going to come up here and type in IP access list, extended, and home. And I'll type in permit IP 30.0.0.0.0.255 to any destination. I don't care where it's going. And allow that to happen. And we're going to say close. We can always activate it later. And now that that's done, we should, oh, you know what the other problem is on this router here, is I haven't advertised the 30 network into OSPF. So I'll type in a network of 30.0.0.0.0.0.255 area 0. So what should happen now is my home router should learn the route, and by learning the route, momentarily the prefix should be allowed to pass through. And so if I go back to my home router, wherever that might be hiding, there it is. So let me go ahead and pull this off out of sight, because I don't want to give my home public IP address away. So we'll type in do show IP route OSPF, and I have not learned the 30 network yet. So do show IP interface brief. Oh, and interface gig 2 no shut. I have a habit of forgetting to enable ports tonight. So once this happens, the interface should come up, and then that route should be propagated. So so that's done. I'm checking the home router. I see the network there, and there's the ping starting to work. So we know that's operational, and so what that means is I have end-to-end connectivity. So if I check on the ASA and I do a show NAT, I have NAT hits. I have 85 translated hits, and the PC should have connectivity now. If I click back in here, I do have internet connectivity. So that's how you would accomplish that goal. So I'm going to go ahead and I'm going to save this config on this guy here, which is the internet. I'll rename it as iNet. Click OK there, and I'm going to go ahead and do write. So that's that. So that's how you would do MPLS and advertise the connectivity. If you see drops like this every now and again, it does happen, but I'm not going to worry about that right now, because that's not my main concern. But that is kind of weird that you know what? A lot of times when you see this is whenever there is high CPU and stuff like that. The ASA will kind of freak out for a moment, but I'm not too worried about that. Show routes. That's weird that it did that. All of a sudden now it's not working. That's hilarious. But anywho, I'm going to go ahead and cancel that ping anyway, because I have connectivity elsewhere. But yeah, that's pretty much it, guys. There's really not a whole lot more to it than that. It is time for us to cut this bad boy off. I have connectivity into the network. I have everything operational that I wanted to get created today, and there's always tomorrow. So I want to thank everybody for hanging out and chilling out with me for the past hour. If you have anything you'd like me to cover, let me know. I will be happy to give it a try. And yeah, so until next time, guys, you guys take it easy. Have a good night wherever you might be. Good morning, good evening, good afternoon, whatever that might be. Take it easy.